Hi everybody, in this video let's look at gradient. So the gradient can tell us how steep a straight line. So what is the formula we use to calculate the gradient of a straight line? Normally we will represent the gradient by using m. So we can use this formula y2 minus y1 over x2 minus x1. Always remember y on the top, x at the bottom here. Besides using this formula, we also can use another formula when we have y-intercept and x-intercept. The formula will be negative y-intercept over x-intercept. If you use this formula, you need to be more careful because you need to add a negative here. So some students, they use this formula, but they forget to add a negative here. So we get the wrong answers. So basically, you have four types of gradient. So the gradient can be positive, it can be negative, or sometimes you get zero, or undefined. Undefined, okay. So if the straight line is going upward or inclined upward, the gradient will be positive. If the straight line is going downward, or we say inclined downward, the gradient will be negative. If the straight line go horizontally like this, parallel to the x-axis, this is 0. If the straight line is going vertically like this, straight go up, parallel to the y-axis, the gradient will be undefined. Okay, let me explain. Let me draw a y-axis and x-axis for you. Okay, this is y, this is x. If the straight line is going like this, going horizontally like this, parallel to the x-axis, the gradient is 0. Okay, same thing, if I have an x-axis and y-axis here. Okay, if I have a straight line going upward like this vertically, parallel to the y-axis, the gradient for this straight line is undefined. Okay, so before I show you how to calculate the gradient, let's look at this one first. Okay, you see this, the red color one, this is the gradient of this straight line. So how do we get this gradient? We can use formula. Okay, let me show you how to get this, the gradient for this straight line. So since now, I told you that we have two formulae, right? This one or this one. Okay, let's check using these two formula, see whether we can get exactly the same answer or not. This is a straight line. You can pick any 2 points on this straight line to calculate the gradient. You will always get the same answers. Okay, how about we choose this point and this point. Okay, now this point, the coordinate is 0, 1. This point, the coordinate is 4, 3. So remember, when you write the coordinate of a point, write the x coordinate first, followed by the y coordinates. And then don't forget to put a parenthesis. Okay, now we use these two coordinates to get the gradient. Okay, let me use this one. Gradient, normally we use m to represent it. So always remember y on the top. So maybe you will think that according to the formula is y2 minus y1 over x2 minus x1. So how do I know this is y2 or this is y2? It's all up to you. You can take this one minus this one, or this one minus this one. But remember, if let's say I take 1 minus 3 for the y part, 1 minus 3, 1 minus 3, I have to do the same thing for the x part, 0 minus 4. Okay, let's check. See whether you get the same answer or not. 1 minus 3 is equal to negative 2, and this will give us negative 4. You press your calculator, negative 2 divided by negative 4, you get 0.5, which is the gradient of this straight line. So let's say, if you don't want to take 1 minus 3, we go another way. We take 3 minus 1. 3 minus 1. Remember, if you take 3 minus 1, when you go to the x part, you have to do the same thing, 4 minus 0. 4 minus 0. Okay, so this is 2, this is 4. You see, you still get the same answer, 0.5. Okay, so how about now we try another formula, which is negative y-intercept over x-intercept. Since that from this diagram, you get the y-intercept and x-intercept. We have the x-intercept and y-intercept. We can use another formula. Okay, let me erase this one first. Okay, how about I erase this one? Okay, done. M is equal to negative y-intercept, which is equal to 1, over x-intercept, which is equal to negative 2. Negative negative will give you positive. 1 over 2 is actually equal to 0.5. Okay? Okay, now let's look at when the gradient change, how the steepness of a straight line will change. 0.5. When I increase this number, when you see positive, right? Nothing here means positive. Positive means that the straight line is going upward. If I change become negative, the straight line is going downward, incline downward. Positive, incline upward. When we look at the steepness, we compare the steepness between two lines, we just look at the number. So you look at this number. When I increase this number, it becomes steeper and steeper, right? When I decrease the number, it becomes less steep. So how about we go to negative? Negative, the same thing. When I increase this number, for example, now this is negative 0.5. If I increase it, negative 0.6, negative 0.7, negative 1.0, negative 1.5, these straight lines will become steeper and steeper. Let's see. You see? Okay, so how about when sometimes the questions ask us which straight line is steeper? When we want to compare the steepness between two straight lines, we only look at the number, we just ignore the sign. For example, if I have a straight line AB, the gradient is, let's say, 1, and I have another straight line PQ. The gradient of this straight line is negative 3. If I ask you which straight line is steeper, so you might think that, okay, 1 is bigger than negative 3, right? So 1 is greater than negative 3. AB is more steep. The AB is steeper. It's actually not correct. We cannot compare this way. When we want to compare the steepness between the two straight lines, we ignore the sign. We just look at the number 1 and 3, which is greater. 3, right? The sign is just tell us that the straight line is going upward or going downward. This positive is going upward. Okay. Positive, now you have a positive number, means that the straight line is going upward. Oh. Going upward like this, and this negative is going downward. And because this is 3, negative 3 is actually steeper compared with this straight line. So PQ will be steeper compared to straight line AB. Okay, now, so since I have a C for you here, I just show you why it's a C. Okay, you look at this equation, y equal to m, and this part is a gradient. You see, this and this always the same. So this is a gradient. Okay, this is a gradient. When it become 1, the gradient is 1. We don't have to write 1 in front of the x. People know that that's 1. Okay, and this part is actually the y-intercept. You see, when I move it, this number is here. When I go to negative, it goes down. Okay. Okay, so now let's see how do we calculate the gradient using that two formula that I just showed you just now. Calculate the gradient of the following straight line. Now, gradient normally we will use m to represent it. So how do we get the coordinate? In this case, can we use the formula negative y-intercept over x-intercept? No. Why? Because now we don't have any y-intercept and x-intercept. Okay, so we just use another formula, which is y2 minus y1 divided by x2 minus x1. 4, 8. Okay, remember to write the x coordinate first, followed by the y coordinates. So how about this one? 1, 2, 1, 2. Okay, now we have the full coordinate of these 2 points. We can start to calculate. 8 minus 2. If I take the 8 minus 2, I go this way. When I do the x part, I have to do the same thing. 4 minus 1. 4 minus 1. Okay, so this is 6. This is 3. 6 divided by 3, you get 2. The gradient of this straight line is equal to 2. So if you want to go another way, you want to take 2 minus 8 divided by 1 minus 4, you get exactly the same thing. So if you want to find this the gradient of this straight line, not necessarily you have to choose these 2 points. You can choose any other 2 points. For example, you can use this one, this point, and this point. Let's try. See whether we get the same answer or not. 2, 4. 2, 4. 3, 6. 3, 6. Okay, now let's try use these 2 points to calculate the gradient. 6 minus 4. Okay, how about now we try go another way. We take 4 minus 6. If I take 4 minus 6, I have to do the same thing for the x part. 2 minus 1. 2 minus 3. 2 minus 3. Okay, so this will give us negative 2, and this will give us negative 1. Negative divided by negative, you will get positive. 2 divided by 1, you get 2. You see? Exactly the same gradient. So from here we know that the gradient of any 2 points which fall on the same straight line will be the same. So you can choose this. Okay, let me label A, B, how about C, D. Gradient of AC, AD, BD, BC, and so on. All will give you the same answer. Okay? Okay, now let's try this part. Let me erase this one first. So actually, before you calculate the gradient, right, you know the answer must be positive. Why? Because you look at this line, it's inclined upward. You know your answer must be positive. If you get negative answers, means that some mistake here. So you have to redo it again. So for example, this one, before you calculate, you know your answer must be negative. If you get a positive number, you know that there is some error, you have to redo it again. It's okay. Okay, now let's calculate the gradient for this straight line. Negative, right? We know the answer must be negative. Okay, let's just choose this point. 1, 8. 5, 2. Okay, so remember y on the top, 8 minus 2. If I do 8 minus 2, I have to do the same thing for the x part. 1 minus 5. So this will give us 6. This will give us, okay, let me move down a little bit. Negative 4. So normally we like to write the negative at the middle here. 6 over 4, then we simplify it. 3 over 2. Okay, so as we thought, negative number, right? Negative gradient. Why? Because it's going downward. So this one, you don't have to calculate, you know. The gradient must be equal to 0. Why? Because horizontally like this, parallel to the x-axis. Okay, let's say we forget. We want to calculate. You can take a try. So this is 1, 2. 1, 2. How about this? 5, 2. 5, 2. Okay, now let's use the formula y2 minus y1, 2 minus 2, 5 minus 1, 2 minus 2 is equal to 0, 5 minus 1 is equal to 4, 0 divided by 4, 0, right? Okay. Now let's go to this. Before you calculate, you know the answer. This one must be undefined, the gradient, because go up vertically like this and parallel to the y-axis. So let's try. Let's say we know the gradient is undefined. So this is 3, 2, and this is 3, 8. 3, 8. Okay. So if you want to calculate gradient, y2 minus y1, 8 minus 2, 3 minus 3. So this will give you 6, and this will give you 0. 6 divided by 0, we get undefined. So the gradient is undefined. Okay? So these are the 4 types of gradient that I told you just now. Incline upward, positive. Incline downward, negative. Go horizontally, parallel to the x-axis, 0. Go up vertically, parallel to the y-axis, undefined. Okay, now let's try last one. Okay, this one, now let's try use another formula, which use the y-intercept and x-intercept. Since that now we have the x-intercept and y-intercept, right? Okay, the gradient is equal to, if you want to use the another formula, don't forget, put a negative first. Negative y-intercept, which is 6, over x-intercept, which is 3, negative 2. And before we calculate, we know the answer must be negative because it's going downward like that. Okay, let's say you don't want to use this formula, you still insist to use this formula. y2 minus y1 over x2 minus x2 minus x1. So how do we get the full coordinates of this? Okay, here is a very important thing I want to tell you, that remember these two. On x-axis, y equal to 0. Remember, on y-axis, x is equal to 0. What does this 2 mean? Okay, so let me use this one to show you. So now I try to put some point here, and you look at the coordinate shows here. All these points are on x-axis. Do you see any similarity between this, or between the coordinate of all these points? You notice that the y coordinate here always 0. That's why I told you just now, on x-axis, y is equal to 0. The coordinate for the y coordinate will be always equal to 0 if the point lies on the x-axis. Okay, now how about if the point lies on y-axis? Okay, let me just do it here. Okay, now look at the coordinate between this all. Do you notice that all the x coordinate, 0. That's why I say on y-axis, x is equal to 0. So remember this, on x-axis, y equals 0. On, let me repeat again. On x-axis, y is equal to 0. On y-axis, x is equal to 0. Okay? Now, if you understand this one, you can use another formula to get this gradient of this straight line. So we should be able to get the same gradient on y-axis, x is equal to 0, right? Okay, and this is 6. This is the y coordinate. On x-axis, y is equal to 0. And this is 3, this is x coordinate. Okay, now let's try to use this formula. y2 minus y1. You want to take 6 minus 0 or 0 minus 6, or up to you. If you take 0 minus 6, don't forget when you go to x part, do the same thing. 3 minus 0. So this is negative 6. This is 3. When you divide, you get negative 2. Exactly the same answer. Okay, so for this video, I just stop here first. I will continue to do a few more examples in the next video. Thanks for watching. See you next time. Bye bye.